Hi, so in this video we're going to talk about how can we create new functions from the functions that we already have. And so what we're going to do is we're going to do that by combining different functions. Okay, so how do we do that? So let's say we have two functions. So suppose f and g are two functions. Okay, then we can define what we call the sum of two functions. We call that the sum, and this is f plus g. All right, and we define this function f plus g of x as fx plus gx. We have another combination where we call that a difference, and we define that as f minus g of x, and that is fx minus gx. Then we have the product of two functions, which is f times g of x, which is fx times gx. And finally, we have the quotient of two functions, which is f over g of x, and we define that as fx over gx. And again, just like with almost everything, the denominator cannot be equal to 0. Otherwise, that is not going to be defined. So let's now take an example and see how we can create these functions. So it's a multi-part example, and I'm going to do that in different parts. So the first thing we have is we have two functions. We have fx, which is x cubed plus 3x squared plus x plus 2, and then we have gx, which is x squared plus 2. The first thing we want to do is we want to find out what is f plus g of 2. So if you remember, we said f plus g of x was fx plus g of x, right? So what if x was equal to 2? Then I have f plus g of 2 is going to be f of 2 plus g of 2, right? So what is f of 2? I'm just going to go ahead and plug in 2 in place of x, and the same thing for g. So that's going to be, so f of 2 is going to be 2 cubed plus 3 times 2 squared plus 2, which gives me 8 plus 12 plus 2, which is, this is 20, 24. Okay, and then we have g of 2, which is 2 squared plus 2, which is 6. So I have f plus g. So I have f plus g of 2 is f of 2 plus g of 2. Substitute the values in, and I get f of 2 we know is 24 plus g of 2 is 6, and that gives me 30. So part B of this example is I want to find f times g, or the product of f and g. We know that f times g of x is f of x times g of x, right? So f times g of 1 is f of 1 times g of 1. So what is f of 1? Well, I'm going to take x as fx and then substitute x for 1. So I get that to be 1 cubed plus 3 times 1 squared plus 1 plus 2, and that gives me 1 plus 3 plus 1 plus 2, and that is 7. And then I have g of 1, which is 1 squared plus 1, which is 2. And so then f times g of 1 is f of 1 times g of 1, which is 7 times 2, and that is 14. Okay, so part C of this example says you want to find the difference of the two functions. So I have f minus g of x, that is fx minus g of x, right? Here no specific values are given for x, so we're just going to use the functions as they are. Fx is going to be x cubed minus plus 3x squared plus x plus 2 minus, now remember we're subtracting the entire gx, so I'm going to put that in parentheses, x squared plus 2. So what I get is x cubed plus 3x squared plus x plus 2 minus x squared minus 2. If you see here, the 2's cancel off. The 3x squared minus x squared gives me 2x squared, so this is going to be x cubed plus 2x squared plus x. And finally, we want to find, for the same two functions, we want to find the quotient of the two functions. So again, we know that f over g of x equals fx over gx, right? And we give this by x cubed plus 3x squared plus x plus 2 divided by x squared plus 2. Right? Remember, you cannot cancel off the 2's here because it's not a common factor. So just leave it this way, and that would be your answer.